Okay, another one here to go. And this is the second program that I have also decided to work on. I'm sorry. I realized in the first video I was doing wee, so I'm actually sorry, sir. So this program too, I also decided to calculate for the Ohm's law. So this is an Ohm's law calculator, something like a calculator, and it is to calculate resistance, and resistance here is equal to voltage over current. So the IO stream as the main library being declared, we go to the using namespace, that's the standards, the C++ standards. After that, inside our main function, we declare the variables. And for variables, we want to be having decimal values, so we declare them as double. And we also need them to decide. So we declared also a choice, a char data type, and we call it choice. For the char, it will contain only one value, or only one character. Yeah, only one character, either A, B, C. That's that one alone. So we tell the user it is an Ohm's law calculator we want to, and then we also declare the formula here that we are being used. That's resistance is equal to voltage over current, and we come here. Here we use the do while loop. Why do while loop? Because we would want to be at least execute the first program, the first code from here to here before we now come and put the condition for the user. So here we let the user to decide. So if a user wants to continue to the program execution, then while this condition is true, then this one, the do while loop will run as long as the condition in the while loop is met. So that's why we use the do while loop. And inside the do while loop, we have a nested if. We have also nested if else statement in the do while loop. And what this if statement is to do for us is to make sure that current is not equal to zero. So when current is equal to zero, resistance, okay, yeah. So we want to tell the user that when current is not equal to zero, so when this condition is true, then we are to calculate for the resistance and then give the user an output as long as current is current is not equal to zero. But otherwise, that's the else. We should tell the user that current cannot be equal to zero. And then also we also leave the user the choice to decide whether he will want to continue or he will not. So this is what, and then we made a choice for him to choose Y for a yes, and then an N for a no. So this is the program, and let's see it in an IDE and how it works. So this is the program in an IDE. Yeah, so we have it here in an IDE. We have our program here. As already explained, you want to run the program and see the result of what we have here. So we debug it in order to check whether we have an error or we are not having an error. So let me see if we have an error. Okay, so code blocks didn't give us any error, and then we can now run the program. Yes, so this is it. When we run the program, this is what we will see. So the Ohm's law calculator, and you are telling the user that resistance is equal to voltage over current. So let's enter the voltage. Let's say we having 20 32.5 or zero point 0.4. Yeah, let me say 0.45. Okay. So and then we also enter current. So current, let's say current is 12.3. Then we calculated for resistance. So this is how we get so does the user wants to continue if y for a yes and then n for a no. So let's say we want to continue. So y, that means we are also calculating for another for another resistance, and then also we also go by the same. So let's assume we enter a value that is 0, and okay, a current that is 0. We said current cannot be 0, so we have been prompted, and we still wants to continue. So let's say a yes, and then we also do another calculation with that for that function too. So now we do not want to continue again because we want to end the program. So we have to enter no, that's n. And the program is now has now ended. Yes, so we can press any key to actually continue. Yeah. So this also the Ohm's law calculator that we too we have been able to also did. No, sorry, I have been able to also design as instructed in the assignment. Thank you, sir.